Okay, good afternoon. Right, we're going to have what's clearly going to be a small, high-level roundtable discussion on this particular topic. So, welcome to this session. My name's Nick Blythe. I work at the Institute of Environmental Management and Assessment. I'm chairing one or two of these sessions throughout the period of the conference. And this particular session, okay, once more. Small ones are more juicy. It's not what you've got, it's what you do with it that matters. Fascinating title. We have the person behind the title on the panel here as well. And it's all about energy storage. So we're going to actually have a discussion and a debate and also some questions from yourselves, I hope, to really explore and get into some of the issues behind energy storage, the technologies involved, the complications, the key drivers and considerations and challenges. So, in a nutshell, there's not much more I can say, really. I think it's best that we start with a short introduction from each of the panel members. So, delighted to have Pama, Nick. They're not sitting in order. So, would you like to put your hand up for each one? Pama, would you like to go first? Pama? You can see their titles behind. Nick, as well. Yes, microphone's coming. Andrew, Graham, Mark. Okay, thank you. Sound like a boy band then, almost, but there you go. So there you go. Right. Okay, is this working? That's working. Okay. So 2 minutes each, please. A couple of minutes to introduce yourself, your interest in this particular topic, and some of the considerations that you've been having. Please don't make it more than 2 or 3 minutes. We'll keep it kind of flowing. Okay, so off you go. No, you can start. No, okay.
Sure. Hi, I'm Andrew Bissell from Sunam. Probably when you think about energy storage, you tend to think about electricity. We do the other bit. We do heat. Heat energy is about 40 to 45% of final energy consumption in the world. Electricity is about 18%. So overall, there's about 2.5 times more consumption of heat energy in the world as electricity. Therefore, we think it's a really important topic that we not only have electric batteries, but we also have heat batteries. At the moment, our heat batteries are used inside houses. They replace hot water tanks, or they complement things like night storage heaters. We're going up the scale, so we're going to be in much, much bigger stores very soon, including mobile stores up to barge scale, which we've announced with Bristol City Council. Thanks.
Thanks, Andrew. My name is Nick Kitchen, CEO of Cumulus Energy Storage. We're enabling renewable electricity by developing the lowest cost, grid-level energy storage batteries. And we're using copper and zinc technology, which was first invented some 200 years ago by Volta. We've turned that into a rechargeable copper zinc battery now. And for us, a small battery would be a 40-foot container with about 1 megawatt hour in it. So our sweet spot is 1 to 100 megawatt hours. The markets would be commercial renewable generation, electricity-intensive industries, and the infrastructure, so transmission, distribution, etc. So we're really all about time shifting of renewable generation. So 4 to 6 hours to charge, 4 to 6 hours to discharge. That's really where we're sitting in the market. So it's high energy, long duration part of the market. So we're not competing with Tesla, we're not competing with lithium-ion, which is in the high power, short duration part of the market. Hope that helps.
Thank you.
Very much. I'm Panos Papadopoulos. I'm with UK Power Network Services. That's the commercial branch or the unregulated branch of UK Power Networks Holdings, the big DNO in the UK. Energy storage. So what can we say about energy storage? It's the holy grail of electricity networks, essentially. It's been for decades. It's one of the few networks, electricity that doesn't have storage. We see now water networks, they have tanks. We see gas networks, they have tanks. We see computer networks, they have storage, local or cloud if you like. We see traffic networks, they have parking spaces, but electricity doesn't really have storage that much. And we see a lot of interest in the last years in electricity storage. So what we're doing is we're developing solutions for our customers from finance through to operation and maintenance. We have developed a team on distributed energy resources, so we're interested in the huge spectrum of energy storage, be it small scale, community energy, large scale, microgrids, virtual power plants. and we're trying to see where we add value to our customers, not only in commercial applications, but how can we increase reliability, how can we improve the business case for them. I think there is a whole lot of applications for energy storage. We'll probably be focusing today on domestic scale, but very glad to be taking your questions.
Good afternoon, I'm Graham Kenyon. I'm an independent electrical engineering consultant, but today I'm here representing the IET, and in particular they have a technical committee 3.3 that's looking at the code of practice for electrical energy storage systems. So that is my main interest. My involvement there is as one of the co-authors of the code of practice, and I'm also deputy chair of Panel D, the specialist electrical installations panel of JPEL 64, which produces the IET wiring regulations BS 7671. So that's why I've been invited to come here today and look at how that fits into the picture here.
Hello, I'm Mark Stanton, Dr. Stanton, and for those of you that did come thinking you were seeing the new latest boy band, I'm the good-looking but exciting one. During my day job, though, I am with a company called Clean Power Solutions, now known as CPSL Group, and we specialise in finding a holistic approach towards all types of energy storage and generation. So I'm afraid the obtuse titles today is actually my fault. They asked me to give the title for my presentation, and they've nicked it, to be honest, but I'm very generous, I'll let them keep it. As an ex-journalist, it got you all here in the first place. So now you're here, we can hopefully tell you about how we can use energy storage, the best ways of doing it, the holistic way of not wasting it. So before you start wasting it, or when you start making it, don't waste it. And that's what we specialise in medium scale generation and storage. And we've also managed to create a way of being able to have any size generation and any size storage and connect it to the grid as a G8 connection. And so we've managed to avoid the usual problems of grid upgrades, etc.
Brilliant. That's great.
There you go.
Thank you. No, thank you, Mark. Okay, hold on to the microphone, please, because before we open it up for questions, I just want to come back down the group, okay? And it'd be great just to hear from you. If you could outline to all of us what you feel is the most significant challenge for upscaling energy storage in this space in the UK at this point in time, and we'll come back down the column on that one. Thank you.
I think the most significant challenge we have at the moment is integrating all the different types of energy on the market within the market. So we all need to be able to work together, and I think cooperation now needs to be the main player rather than competition. So if we can find a way of being able to, for my clients, generate enough energy that they need. It's about matching supply to demand. Don't make it to waste it. Don't send it to the grid if you don't have to. But find the best way. It may be that turning some of it into heat may be a better solution. It may be that turning some of it into storage may be a better solution. We even have a solution with my own company where we can turn it into hydrogen and use the hydrogen as vehicle fuel or as heating fuel. So it's finding the right solution that's going to be the important
Okay,
thing.
thank you, Mark. Lovely. So just a quick view, really, from each of you. I'm sure we could do that.
Well, I've been looking a lot at safety of the electrical installations, particularly when operating off-grid and switching between the different modes of operation and making sure that you've got continuity of supply where it's required, but also maintaining the safety of that installation, particularly under conditions where you might no longer be able to use the supplier's earth. There are solutions to all of these problems, so they're really just challenges, not problems. However, keeping it cost-effective and compliant, conformant, is perhaps the big challenge there.
Thank you. Hannah, thank you.
Thank you very much. So from our point of view, I think there are a lot of regulatory challenges right now that are existing, and they are not really helping in the huge uptake of storage. So, for example, the uncertainty in the classification of storage right now is one of them. Double charging is the second one. We think that if we go forward and try to find solutions on these challenges, then this will give incentives for people to start investing in this technology. We need of course to overcome barriers such as simplifying solutions for installations for GT3, G59 and so on to make it easier, but we think going forward with smart meters as well and maybe half-hourly settlement, more transparent tariffs will be created and more cost-reflective, if you like, prices of electricity will be available to customers and make it clearer on how they can access markets and get revenue for it.
Thank you, Hannah. Thank you.
I'd echo what the previous two speakers have said. I would also add that one of the challenges here is to be able to industrialise the energy storage to get it to scale quickly. So a little bit of help from the UK government would be good for demonstrator projects. And I know I've said that before, and I'll probably say it again. But that's key. We have got a major opportunity here for UK PLC. Let's grab it. Let's make it happen. So it's not really a problem. It's actually an opportunity, which I think we should do something about.
Nick, while I'm with you on that, can I just ask you, because you mentioned government support, and many people, I don't know.
We've had some government support, by the way.
There has been some. Okay. What is the current sort of government support? What's the mechanism for this?
Well, if I can just say what we need rather than what's available.
Okay. Got it.
If that's politically
You can say both if you
reasonable.
like, yeah.
So what we need is, as I say, is we need some support to facilitate demonstrator scale projects out there, prove the technology, and then that will then result in the potential industrialisation. But I'm talking here about a complete range of different kinds of storage. It's not just us, it's the industry DEC.
Sure.
When they were around, did a great job to get a whole portfolio, and Andrew's an example of that. So let's get that portfolio of companies to take it through to industrialise, give a series of solutions out in the marketplace that together can help drive the energy storage market for UK
Thank
PLC
you.
and indeed the world.
Okay, thank you, Nick. So the loss of DEC going into BEIS, it's pronounced, Business Energy Industrial Strategy, is not necessarily a bad thing in this space. The focus on the industrial strategy could be an opportunity for some support to be pushed through.
Time will tell.
Yes, okay, thank you. Thank you.
So for us, with our I mean, actually, I agree with a lot of your points, Nick, and certainly large-scale demonstrators, I think, are critical. We were very lucky that Scottish Government supported us with a very large-scale demonstrator with 650 homes, so that was very important that was social housing. But when we come to very large projects involving, marine transport, for example, of heat, from waste heat facilities to district heating, those are capital intensive, and yet there's a real demand for those. I think probably our biggest challenge is the low price of gas, and maybe in the back of it, that's actually the challenge also for the electrical side, because low price of gas means low price of combined cycle gas turbine electricity, and I don't know how that impacts, but certainly on our side with heat, low price of gas is a challenge. Luckily, we've been able to perfect technology that allows you to use heat storage and a heat pump to actually run it below the cost of gas, and we think that's quite breakthrough.
Okay, thank you. Okay, well, thank you very much. So we're going to go over to the audience now and ask if there's anyone with particular questions on any aspects of something they've heard about that you'd like to explore a bit further. First of all, so got a question at the front, thank you. And could you tell us who your question is aimed to as well?
Thank you. Good morning, my name's Wayne Harris.
It's not, actually.
Yeah, it's on. Morning, my name's Wayne Harris, or afternoon, it's afternoon, isn't it? From a housing association in the North East.
Yeah. Do you want to
much closer.
take this mic here, and we'll grab it back in a minute.
Yeah, I'm constantly coming across individuals in the industry who are saying to me that in the context of a domestic property, that battery technology isn't where it needs to be yet. It won't be for about 18 months. I'm just on the brink of an install program for 2,000 social housing properties that I want to put PV on, and I also want to use battery storage. I'm just wondering what your views are on that. I'm sure who the best person is to answer that.
So if anyone didn't hear that, it's a question about the battery storage capability, whether it's up to what is required. So we'll come, if anyone would like to come back on that one.
I know we're not in the domestic market, but I can still give some There is an existing market. There are existing solutions, lithium-ion, so Powerwall product from Tesla, you've got Mike, so a whole range of different companies in the UK are already providing the domestic, if you like, solutions for storage. It's there, it's already there.
Right.
Looking at different offerings from the market, as Nick mentioned as well, we see that the payback, like the period which you need to wait in order to get your investment back, is over 10 years at the moment. There are minor cases where you can see that being down than 10 years, but looking at warranties offered for small-scale energy storage systems, you are lucky if you arrive in 10 years with the same capacity that you started in the beginning. So we see as the current business case for domestic energy storage clearly marginal, so it's not very, very clear yet from the economic perspective. But there are other drivers as well. So there are people that maybe they want to get first into this technology, they appreciate a lot of reliability in case of blackouts. So there are other drivers like that, energy independence, that people want to investigate on top of that. But on the economics only, it's for us, it's very marginal at the moment.
Hannah, thank you. You can go to Mark and then we'll come on to another question if there's one from the...
Yeah, it's an interesting question, and it also really depends on what you classify as domestic. In most instances, domestic in this country will be classified as what's called G83, and that's the limit that you're allowed to connect to the local grid network without actually asking for special permission. If you have to ask for special permission, it's called a G59 connection, and it can be refused, or you can have to pay for the upgrades, and that can be a lot of money. I mean, 30, 40, 50,000 pounds is not uncommon, or 2 million, I think the largest I've ever had. So because the limit is 16 amps per phase, on a normal house, a normal domestic house, that equates to about 4 kilowatts, which is why most houses, when they put up solar panels, put up about 3.68 kilowatts, or 4 kilowatts of solar PV, because that complied with the G83 regulations. You didn't have to ask for permission, you just put it up, wrote to the electricity company and said, last Tuesday we put up 4 kilowatts at Mrs. Miggins, 27 a case, you're having it. So because most domestic houses only put up 4 kilowatts, there's a limit really as to how much power they could make that they could save or store. So that gives them one limitation, and because of that limitation, you've then got the problem of what's called the spark price. And the spark price is the difference between what you get from selling the power and what it will cost you to buy it back. Now at the moment you get about 5p a kilowatt if you sell the power, and it costs you about 15, 17p to buy it back. But if you have a domestic system, you don't even get that 5p. You give the power away and you get what's called a deemed power allowance. You get paid for giving the deemed power. So the actual spark price is bigger because you have nothing. So you might as well use it all yourself because they're going to pay you for it anyway. So something like a SunAmp system would be much better because you send the power. You've probably only got 2 or 3 kilowatts of extra anyway. Put it into heat.
Okay, Mark,
that would make a much better system.
Sorry, thanks very much. Thank you. We'll just come over to Andrew for a quick word on this.
Maybe later we can talk about how heat could be part of your solution.
Sorry, I missed that. Did that work? Did the mic work?
It did.
Excellent, excellent. We're going to stick with this one because maybe the panel will be a bit used to talking a bit more than the audience, maybe. So, any further questions, please? Who's next? They're coming. They're just thinking about it. They're coming. Can I ask a question while I mean, there's two things that I don't know enough about this topic area. I'm fascinated by it, and a really simple question that might help me to understand and others to understand a bit more about why we need this. So traditionally, on the grid, there have been. You said there've been no storage, and I agree with you. I understand what you mean by comparing that to water grids and things like that. But that made me think, of course, because there has been storage equivalents on the grid, because we had things like the large dams that have been built, that kind of release. So if we had more of those kind of capacity mechanisms, why is it that we need different methods of storage beyond that? That's just a kind of simple question, first of all. So I know, very basic, but why do we need it beyond that?
It's good. I think the new interest, high increased interest now in storage and battery storage in particular, because as you mentioned, we have different types of storage already in the network, has been driven by increasing demand, electric vehicles, climate change concerns, increase of renewables as well. So we see that when we are able to store electricity closer to where it's produced, this essentially leads to a much more efficient electricity system, much more efficient and reliable power system. You have less losses, you can store it and take it back whenever you want.
So it's the changing nature of the grid, the need for picking up on the renewables,
Absolutely.
decentralised
So with the renewables, we see
everything to do with
power
that.
flows changing from
Yeah.
downstream to upstream, and having storage, we can use it as a buffer to balance these power flows to have a more efficient power system, a more reliable one.
Thank you.
I think one thing that people don't really realise is that the variability on the electricity grid is sort of like this. It kind of goes up and down a little bit. When you compare it with the gas grid, which kind of goes from the floor to the ceiling and back again in terms of daily swings. And the gas grid actually has multiple days of storage in it, in terms of the pressure in the pipes and the ability to vary that pressure. Salt caverns and various other things are in development. So we shouldn't forget that energy storage is a much bigger topic than just electricity. But if you think about those pump storage hydro systems, there's just not enough sites to have massive amounts of pump storage hydro. And we therefore need a lot more distributed storage in the network and at the point of use. And that's the reason why, 50 million small batteries and batteries all up and down the grid system will ultimately end up being in existence, we think.
Yeah.
And those will include heat batteries and electric batteries, both.
Okay, thank you very much, and thank you.
There's also the problem of intermittency, and it's not just the intermittency of renewable resources as to whether the wind is blowing or not, or whether the sun is shining or not. And one of the design faults of solar panels is they really don't work very well at night, which is when most people want to turn their lights on. So it's that intermittency, but there's also the intermittency that was never there before. Before, the generating stations used to be able to work out pretty easily what time Mrs. Miggins and her family got up in the morning, what time they went to work, when the machines were turned on, when they came home, had their tea and went to bed, and were all little good boys and girls and took the plug out. Now we live in a 24/7 economy. The demand's going up and down all over the place. The production's going up and down all over the place because of renewable resources. So you will get problems of reactive power, of phase imbalances, because they don't know how much they need when they need it. And so they need to be able to respond quickly. So they need the energy storage, such as pumped hydro, or such as Nick's Cumulus Cloud System, etc., that can quickly respond. Now that quick response may come from lithium-ion batteries to give immediate response, but then backed up by other power storage systems to give the main power behind that. So it all has to be, it's the mixture, it's the holistic approach to get everything working together that's needed.
Okay, thank you for all of those answers from the panel. That's grand. So, okay, we have a question here. Thank you. Can you just test that and make sure that works? Okay.
Hello? Yeah.
Excellent. Thank you.
Yeah, my question is, how do you see the integrated and efficient approach of the between the domestic and industry's power grid with the consideration of renewable energy resources?
So,
It is a major problem. What the question was how do I see the integration between the domestic and sort of the standard grid system?
Yes, it is not just integration, it's an optimized and efficient integration.
The efficient integration is important. I mean, as I mentioned before, the main domestic integration is with what's called a G8 to 3 connection, and that gives a limit as to how much power they can actually export. It's roughly 4 kilowatts a phase, 16 amps. Now, for a domestic situation, the other problem you've got is if you store the power, you can only release that into your domestic system within that 16 amps per phase. So it means that if you've got the dishwasher on and the electric kettle and the television, you're not going to be drawing all that power from the batteries, and even if you could, you draw it very, very quickly. So what my company do for the integration is we store much more power. We'll store a day's worth of power, and be able to top it up from the cheap night time with electricity. So we top it up at night, and we can supply it to the site in 5 kilowatts or 10 kilowatts, whatever the site needs, because we work behind the grid. So we developed and patented a way of doing that. So for the integration that way, there is a solution. But as a general rule, there probably isn't, I don't think, going to be a great deal of integration between domestic renewable energy and the grid. It's going to come more from larger scale domestic, sort of agricultural and factories, etc., that will use it in slightly different ways.
Mark, with due respect, I'd like to disagree. Various actors in the foresight industry, including the Rocky Mountains Institute, have come down very strongly on the side of saying that distributed storage which is the furthest out you can possibly go, in other words, behind domestic meters, is actually the most powerful at delivering services to the grid. And I think we need to look very carefully at what they're saying, because I think they're probably right. The further up the grid you are in terms of delivering energy storage, yeah, it's definitely easier. You put big batteries in centralized locations, it's much easier. But actually the number of services you can deliver, including frequency response, local balancing services, local feeder services, behind the meter, self-consumption services, those go up every time you move further down the network. And so I think what we're going to find is that actually, in the end, most of the storage will be in the home or in the business behind the meter. And what we will have is a massive amount of software managing and market rules that correctly reward people for the services they're providing. I'd say those market rules are absolutely absent at the moment, but they will be present eventually, because the market needs them.
Do you want to have a quick response? So Mark and Andrew, just thank you, because you've just injected a bit of disagreement. And
The man's an idiot, what did I say?
that just helps so much in these conversations.
Get the knives out.
Okay.
Yeah, I mean, to a certain extent, Andrew's absolutely right, that, you know, there is going to be a response, there is going to be behind the grid response. And it's, if you look at something like Australia, you've got a massive market there where really the only solution is for them to store it and make it themselves and almost become mini distribution networks. And that's partly what our system does, is it stores it behind the grid within a synthetic grid. And that's what our patent covers. My argument would be whether or not Mrs. Miggins at 37 Acacia Avenue is going to have that much of an influence on it, because as you say, she's further up that grid. Once you get further out to the agricultural and to the commercial side, the SMEs, the distribution companies, the small factories, etc., then I think that is exactly where energy storage will be. But it has, at the moment, as you say, the regulations, the G83 regulations, and the fact that the grid can't take, in many cases, any more import. You look at Scotland, you look at Cornwall, you look at many other parts of England, the grid's turning around, throwing its hands in the air and saying, we can't take any more, Jim, we're full. And, you know, the answer is, please just don't give us anything. And when we turned around to certain DNOs and told them that we had patented a way of connecting 100 kilowatts of generation and 200 kilowatts of storage to the grid as a G83 connection, first of all, they laughed. Then we showed them the plans, and they had a bit of a Tourette's moment that went on for several months, certainly some of the more Scottish ones. And then we proved it to them, and they really didn't want anything. But you're right, the rules are going to have to change, and we're going to have to find a way of being able to blend it and work it all together. Because otherwise we are going to have big problems.
Okay, Mark, thank you very much. Yeah. Did you want to come in, Paradise?
Just like to continue on
yeah,
that,
please
because essentially
and we shall move on to,
there's
a host of questions out there.
I think that's great, and I agree with that, different storage sizes and systems in different locations might be able to do different things for the electricity system. So grid scale storage is needed for particular locations where there might be congestion, for example, a different location where we have a voltage issue, and small scale storage system will increase the efficiency of the network because they reduce losses. Energy storage in electric vehicles will essentially be able to help as well, because they are parked for more than half of the day. So we need to look at its technology and size from a different perspective and try to do a whole system approach and try to see what's the best for different sizes. Try to help inform policy and inform the government of why we need that and why do we need that going forward, and from then develop roadmaps on how we are going to arrive at different let's say targets for its technology, if we like, and then try to work on it. The second point I'd like to make here is essentially starting from what you said as well. We need to create knowledge sharing between the customer, the DNO and the TSO, and this is starting happening right now. So the DNO start cooperating with the TSO, with National Grid, on how they can develop services which are shared for storage and other flexibility providers. Essentially, when I'll give you an example. When the TSO requires frequency response from energy storage that is connected to the distribution network, this might create a problem to the distribution network operation. So there needs to be clearly an interface where the DNOs and the TSO need to share information, collaborate, in order to get the best for them and for the customer. So I think a collaboration and the whole systems approach will help.
So that's really helpful, thank you. So I can see there's lots of pros and cons on different aspects of that discussion, but in a nutshell you were saying that, I picked up you said that the T&D, the transport and distribution losses are less further along the grid in terms of when you're up towards the domestic end. Is that the essence of what you were saying?
Clearly, when you have storage, essentially, and when you have your demand very close to your generation, then the less losses you're having.
Okay, yes, just purely because of the yeah, okay.
Of course, you're reducing your losses. But however, now the losses that we see in the UK vary in different DNOs and for different types of networks, rural, urban and semi-urban, from maybe 6 to 9, 10%, it depends, with an 8% average.
Yes.
We can reduce that. This can reduce the bill to the customer, but we can help that with storage system using the 4-quadrant capability of the converters by using reactive power to improve the power factors of different locations.
Very, very quickly before we open it up again, you mentioned vehicles and the use of vehicles as storage. Is that happening? Are there any examples of that happening already?
There are some examples, yeah. So we have some projects happening around the UK, but it's not as fast as probably we would like that to see. We are participating in some projects as well, trying to see how we can control the charging of electric vehicles in order to provide services, deferral of reinforcement, but even services to network operators as well, but it's fairly slow.
Okay, thank you. So if you want to hold on to the mic for a second, did you want to comment on that?
Well, yeah, I mean, the manufacturer, I believe, is Nissan,
right,
who's up there with a product that you can charge your car with it, you can use your car as storage. So.
Oh no, forgive me. I understand that, but I wondered. I've read some. There's a recent project that won an award. I think it was looking at Corby. This is one of the ICAW awards, and this was looking at an initiative where they would use storage within vehicles charged overnight on a domestic level out in the neighbourhood. I was wondering whether any were coming through on that level. That was my thought.
I think that's the only study at the moment.
Right, okay.
But I mean, you could buy a Nissan car.
Yeah, you can on an individual level.
Yes,
of course, yes, absolutely. Of course. Thank you. So, any further questions? Coming back out to the audience here, then. Thank you. Yes, we've got one mic next to you there. Thank you. Could you say who you are, please, as well? Thank you.
Hayden Scholes, Royal Armstrong. I have a lot of clients, mostly solar and wind, who've got constrained grid connections because of the state of the grid in the southwest. Beat your 2 million. I had a grid connection offered for 7. It's that bad. I mean, Hinkley just kind of taken one of the main links.
Can we hear you? Okay.
Can you hear me?
No, you might. That's better. Thank you.
Okay.
Thank you.
What we've been looking at with some clients is mixing solar and wind on the same site to optimise a grid connection. But we've been seeing some pushback from the DNOs who have basically constrained, say, wind turbine output in the summer to allow more solar PV to be put on the grid. I just want to ask the panel generally, have you seen the same problem coming with storage? Because we see that as the way to fix both of these problems.
Okay, thank you for that question. Thank you.
Yeah, absolutely. I mean, we're in Scotland. That's where we're based. We see an awful lot of grid constraint in Scotland. That's absolutely the same, I think, in the southwest. We're actually on a number of sites now developing heat batteries for local heat uses on sites that essentially have no grid connection. or they have 100 kilowatts of grid connection, and yet they have some kind of grid scale generator, whether that's a wind turbine or a PV. And you could argue those wind turbines and PVs have gone in to get in ahead of a cut-off date, an artificial cut-off date created by the very rapidly changing landscape for subsidy. I think that's true, but nevertheless, those people actually want to use the energy wisely, and so one way they can do that is by storing heat and then moving that heat to somewhere else in their estate or to neighbouring properties where that's needed.
Thank you. Thank you.
I agree with the premise of cogeneration. Solar PV plus wind plus storage equals the new generation. Distributed, I'm afraid the old centralised gas-fired, coal-fired and all the rest of it power station, that model for me is dead. So this is the way it's going. Does that help?
The problems you're having are precisely why we developed and patented our system. We had a lot of problems, mainly up in Scotland, in particular on Orkney and the outlying islands, where overnight the local electricity company, the DNO, turned around and said, as of tomorrow, all connections, that's it, you're constricted, can't do anything. And especially you've got the same problem down in Cornwall, and if you have a mixture between wind and solar, you're making the most, the best, etc. But the old days of put me up as much as possible and send me my feed-in tariffs to Barbados, because to hell with farming, I'm out of here, they've gone. And it's now about finding a holistic approach and finding the right solution of what you need and what you can utilise yourself and storing that. So it's available when you need it rather than only when you make it. And you then have the problem of how you're then going to connect that to the grid. And if it's done properly, it can be done.
Okay, so you want to come back with one quick response? Thank you.
I kind of agree at the small scale, but my clients are anything from a megawatt to 50 megawatts. So
I was quoting.
It's very difficult to find. The biggest heat load in Cornwall is about 3 megawatts thermal. What we really are looking for here is flattening out the intermittent generation. Storage has got a big role to play in that, and not just battery storage, but there are lots of other interesting technologies coming forward. It'll be interesting to see which one of them's actually become commercial. But I just see is it a logistical, or is it simply established points of view within the DNOs that these things are so difficult to get into service? They're roadblocking all of this.
It's about balancing it. If you're going to try and make a megawatt of power just to make it, that's not going to work. These days, if you want to make a megawatt of power and you have a use for that power and you want a buffer system, then it can be done. I quoted Saturday, I finished the quote, for a megawatt. So it can be done. And certainly with things like Cumulus, that would work really well as well.
So we'll come to Nick, thank you, and then we'll go back to some more questions. Thank you.
This is exactly why we developed a low-cost copper zinc battery to deliver 4 to 6 hours, time shifting of renewables at scale, 1 megawatt hour to 100 megawatt hour scale. That's exactly why we've done what we've done. So just make one other comment, and that is that the generation in the UK is changing. It's becoming much more distributed. Obviously solar PV and wind don't have the same, certainly solar PV doesn't have the same level of inertia as the previous spinning equipment, the generators and such like. So the reason we've got the National Grid Enhanced Frequency Response tender that's just recently been awarded is for exactly that reason. We need to have very rapid response capability in terms of energy storage in order to be able to keep that frequency at 50 Hertz and not varying too much. So that's another reason for needing the grid scale energy storage. So you've got the two parts of the market. You've got the high power, short duration part of the market, which is hence lithium ion as the incumbent technology. Next to that, you need the high energy, long duration part of the market. That's where we said, that's the bit that's missing at the moment. Watch this space.
Nick, thank you. Thank you. Hold on to the mic for a minute. Right, any further questions? Just one at the front here, thank you. And please say who you are, thank you.
My name's Ahmad. I work for a student accommodation provider, and we're looking at energy storage for duos and riddles. The issue we're having is a lack of space to store the batteries. So do you have, or are you aware of any technology either in development or currently available which fit that use?
Thank you. Thank you.
Could you say a little bit more about the scale of the storage that you're looking for?
It's probably around 4 gigawatts per annum electricity consumption.
And how do I convert that to kilowatt hours or megawatt hours of storage? I don't know your use patterns. Have you analysed it?
No.
Okay. I guess you need to work with some M&E engineers and probably really drill down into what that means in terms of storage, and also ask yourself, what are the loads? You know, if the loads are running electric showers, come and talk to me. If they're running, lighting or computers, go and talk to some of the electrical storage people like Sonnen, Tesla, Moixa. They're out there waiting to help you. I would say they have solutions today.
Yeah, 40% of our load is hot water.
Talk to me.
Very good, very good. Right, thank you. So, any further questions? So, while you're thinking about that, I'm just going to ask, there's been some really interesting discussions come through from that, and quite a lot about the innovation space. Could we look forward to the next 5 to 10 years? So, in 10 years' time, we are going to have a lot more electric vehicles. Is that itself going to be an issue that's going to shrink this market? Just a question, don't know. What is going to happen over the next 10 years, and what are the innovations that you see in this space? See, I'm full of rather big questions today, but I'd like to start with this one.
Yeah. So I think the most important thing is not a technical thing. I think the most important thing...
Can we all hear, by the way?
Sorry. The most important thing is a market-related thing. We need the market to have rules that rewards people for offering their storage in terms of service. So if it contributes to frequency response, or that's the obvious one, but if it contributes to avoided reinforcement of the service offering of the DNO, if it contributes to a host of other services balancing, some of them you can monetize directly, some of them today you can't monetize at all. And so, in a sense, some people are taking, in my view, full advantage of other people's investment. To my mind, you will see people saying, I'm not letting my EV battery be used until you start rewarding me for that. And the same will apply to all of the other kinds of storage that are out there, or that could be used for it. We need innovation in the market rules. And
so
in my view, that's really important.
Okay. So it's making the market work. Thank you very much. Okay.
Well, I think nobody knows the future, but if I could take a guess, I think looking at how the markets are growing now in energy storage, what we would like to see is a change from the current regime where we have lithium-based systems that were not really developed for these applications. They were developed for consumer electronics, and we got them. We say, okay, they fit. Let's put them into grids. Let's put them into houses. Let's play with them. Okay, they work fine, but they are not built for that. So what we would like to see, maybe new technologies that are much cheaper, much more compact, and fit for purpose for the specific application. So you need a different technology for frequency response, a different technology for peak saving. Lithium works, I say that again. It does what it says on the tin, but it's not made for that. So that's one of the applications. We see probably innovation in how business models will work and how markets will evolve. So we see maybe peer-to-peer markets coming in and more community energy systems being developed. That's a decentralized, as Nick described, energy model in comparison to the centralized that we have now. We can see microgrids or more virtual power plants being developed as well. So we see different technologies coming in to enable that. Data from smart meters, hopefully, will create analytics and new insights on how to create new tariffs. So we see innovation in many different spaces connected to storage, but let's see, nobody knows.
Hannah, thank you. Nick, did Nick or Graham want to come in on this one?
Yeah, I think it'd be very interesting to see how smart grid integration changes the face of all of this. I know that there's an awful lot of bold statements being made about smart grids now, but it's certainly an opportunity for people to start working together and maybe using the export capability that we'll have distributed through the grid to take away from the peaks of electric vehicle charging, for example, that almost certainly will happen if the government's targets on electric vehicle sales are going to be realised. So, yeah, I think very important there.
Thank you very much. We'll come to Nick in the end. Thank you.
Personally, I think there's going to be a lot of innovation in small-scale generation within individual properties, so combined heat and power plants. I think we'll have a lot of development as well within heat storage within individual properties. I think that communities such as factories, warehouses, etc. will develop smart synthetic grids to control their own energy usage and production on site, and so reduce demand within the rest of the network. But of course one of the problems is that although energy efficiency improves every year, energy demand goes up. But one of the things we're never going to replace is the fact that 85% of our energy needs is probably about heat, and that will probably come from some form of fossil fuel, unfortunately, which will probably be gas. And whether you'll be able to see someone's saying, see, I'd like to start the argument. Whether you'll be able to replace all of that with electricity, I don't know. I hope so, but I don't know.
Thank you. We'll come to Nick. Thank you.
I'd like to talk globally, please, for a minute. If you look at what's going on in California, as you get more distributed solar PV generation, you get something called the CAISO duck curve, the California Independent System Operator duck curve. If you haven't seen it, it's all about the amount of power that the CAISO has to cope with. And essentially, the more distributed generation you've got, the less the power required by the CAISO is during the daytime. So you create what looks like the belly of a duck. If you go to India, India is currently forecasting to put 175 gigawatts of renewable generation in between now and 2022. In India, people don't talk about the duck curve, they talk about the giraffe curve. At around 6, 7 o'clock at night time in California, there's a very steep increase in the demand and it creates the head of a duck. If you talk about India, that neck is really, really, really steep and very, very long. It's going to be a major, major problem for places like India. The only way to sort that out is to use grid-scale energy storage. That's where we've positioned ourselves, that's where it's going. Decentralized generation is the way forward with storage. That's what the world's going to look like in the future.
Okay, thank you. Right, I think we're getting near the end. There's one more question. Can I just ask, are there any other questions as well? We'll cover these two. Well, there's two here. Could we take the 3 questions and then we'll come back and you can, between you, answer them as close as, which one suits. So we'll gather these 3 questions together. Thank you.
Hi, this is Arup there. Going back to your interesting point of the electric car innovations and the efficiency. My question is, apart from the technical innovation, how do you see the availability in the longer terms? It's a question of another 5 to 10 years, so that general public is aware of the logistic arrangements and availability of such recharging systems, say on the highway. Unless otherwise the system is not made, technically maybe it's correct, but it will be very difficult for people to move back to electric systems if we do not have a proper plan of such logistic arrangements. So how do you see that in the near future?
Just so I'm clarifying that, your question is one about how do you see the infrastructure being put in place?
Infrastructures and integrated with these renewable energy resources.
Thank you. We've got that question. Is that okay? We've got that caught, yeah. And 2 others. Thank you.
My name is Miles Crossley. I work for George F. White. We work for a number of landowners in the north.